Hey everybody, looking at radicals and other roots. Previously we spoke of square roots. And with the square root symbol, it is an understood 2 that is written there. Okay, it's an understood 2. But we just do not write it. Leave it blank. So what we're looking at are other numbers being written in place of those. And we call that other number the root index. So in this case I have a cube root. The number 3 is the root index. Again, this is the radical and this is the radicand. The cube root of 27 is 3 because 3 times 3 times 3 equals 27. Square root symbol, cube root symbol, and then for our other roots, they do not have a specific name. We just say the fourth root or the fifth root. So I've just written in a C there to indicate the different ones, fourth, fifth, and so on root. With other roots, negative numbers can be under the radical with indices greater than 2 and still have a real number answer. And here's your set of rules for that. If the index, the root index, is odd and the radicand is negative, then the root will be negative. So for an odd root index and there's a negative under the radical, so for instance using the example that we have up there, then the root will be negative. This equals a negative 3. Because what I know is that a negative 3 times a negative 3 times a negative 3 equals negative 27. If the index is even and the radicand is negative, then no real number root. Square root of 4. I'll put a negative sign with it. This is an imaginary number. I cannot get a number times itself, for instance, a negative 2. So a negative 2 times a negative 2, well, that equals a positive 4. I cannot multiply an even number of negative signs together and get a negative answer. So that is not true. I cannot multiply an even number of negative signs together and get a negative answer. Whenever you multiply an odd number of negative signs together, you get a negative answer. An even number of negative signs will give you a positive answer. I cannot get a negative 4. So let's take a look at some examples for radicals that are dealing with other roots than square root. So I have here the fourth root of 81. So what I'm looking at is what number can I multiply times itself 4 times and get 81. Well, let's look at 3. 3 times 3 times 3 times 3. Well, 3 times 3 is 9 times 3 times 3 is 9. What is 9 times 9? 81. I know that the fourth root of 81 is 3 because 3 to the fourth power equals 81. Here I have a negative sign in front of my radical symbol. This is the negative fifth root of 32. I'm going to treat that as a negative 1, right? And I need to think of something times itself 5 times. It's going to equal 32. Well, let's look at 2. 2 to the fifth power. So 2 times 2 times 2 times 2 times 2. Well, 2 times 2 is 4. 2 times 2 is 4 times 2. Well, that's 16 times 2. Well, that's 32. I know that this equals a negative 2 because I'm going to take this negative sign, treat it like a negative 1, and I'm going to multiply it by the fifth root of 32, which is 2. That gives me a negative 2. In essence, what that turns into is a negative 1 times 2 to the 5th. Well, leave off the negative 1, because 2 to the 5th equals 32. And then times a negative 1. Alright, what I would like for you to do is pause the video, and I want you to work the next 4 problems, and let's see if we end up with the same answer. Okay, negative sign under the radical, but I have an odd index, so there should not be any problem with that. I will have a real number solution. So I'm looking at a number that I multiply by itself 3 times and end up with a negative number. Well, I say a negative 2. A negative 2 times a negative 2 times a negative 2 equals a negative 8. So it's the same as saying a negative 2 cubed equals a negative 8. Therefore, the cube root of a negative 8 is a negative 2. The next one we'll look at is I need to think of a number times itself 3 times to give me a negative 125. So I'm going to say a negative 5 cubed, because a negative 5 times a negative 5 times a negative 5 equals a negative 125. So I know that this equals, and I'll rewrite it here, it equals a negative 1 times, what did I get? A negative 5, which equals 5. Again, that negative sign in front of the radical just simply means a negative 1. Next one. That is an even power. That's even root index. Therefore, no real number answer. It's imaginary. And the cube root of 0, simply 0. And those are some example problems for dealing with radicals of other roots. Ladies and gentlemen, please critically think and structure your homework, and good luck on your remaining homework problems.